These are just becoming more and more complex. I've tried to put all of the steps in for you to show you just what you need to do. Things like this, you have to expand the brackets out. And once you do that, you can gather them together and it starts to look like the ones we've just been doing previously. Again, there's the check. Continuing on, looking more complex, but again, you just have to expand all those brackets out and then you'll find ways to gather them together, shift it all around until you get finally x equals. These ones here too looking a little bit more difficult, but it's really the same sorts of things. When you've got something like this, there's actually two ways I could have approached this. I did it by multiplying both sides by this, and that removed it from here, put it over here, and then it became fairly simple. I could have used a reciprocal rule because of the fact that this is a fraction and that's a fraction. If you've got something like this, whatever, I can use the reciprocal by flipping both sides. So flipping that over, I get taking the reciprocal of that is the same as taking the reciprocal of that. Again, I did the same thing to both sides, so that works out okay as long as I do the same thing to both sides. Yeah, so this will be one here too, taking the reciprocal, as I said, flipping them over, and it becomes pretty straightforward after that. Watch out for things like this, E. You know, we haven't forgotten the chapter about factorisation. So here we end up with, if we subtract that from both sides, we end up with this. And straight away you should look at that and say, oh, that's a difference of 2 squares. I can use this factorisation rule that I learned in chapter 2. So don't forget those. Where are we? Alright, I'll leave. Yeah, I'll just briefly mention this. This one asks us just to say whether this statement is always true, or sometimes true, or never true. And so as you go through it, the always true is when you find that one side does equal the other side. The never true is when you found something like this, that this is just impossible. It doesn't matter what the value of x is. Whatever that turns out to be, 6x on both sides is always going to be the same, but this is plus 3 and plus 1. It's never going to equal the same thing. So it's just a nonsense, and it's never going to be true. This one here, whether it's sometimes true, so notice when we expanded this out and this out, we end up with 5 minus 15x equals 5 minus 3x. Now clearly whatever value of x that you put in here, you multiply it by 15 here, you multiply it by 3 here. So this is going to produce different numbers, except when x equals 0. Because if x equals 0, that equals 0, and that equals 0, and you've got 5 equals 5. So that's a sometimes true. In fact, it's only true if x is equal to 0. So look for things like that. Continuing on, this is where you're going to have to write down an equation. Look at this one here. It tells about a woman. She's lived a quarter of her life unmarried, a half of her life married in a first marriage, 1/6 of her life in a second marriage, and then 8 years as a widow by herself. How old was she when we died? So you need to do something like this. Let L equal the length of her life, and so then you say, well, if a quarter of her life she was unmarried, then it's 1/4 L she was unmarried for. A half of her life she was in the first marriage, so it's a half of L in the first, 1/6 of L in the second, and 8 years, we don't know what relationship that is to L, as a widow. But what we do know is this quarter L, a half L, 1/6 L, and 8 all adds up to whatever her total lifespan was. So that's where we get this equation. We then need to gather it all together. Notice we've used some factorisation here to get an expression where you end up with L equals some number. It turns out to be 96 years, so despite all those marriages, she did quite well, didn't she? Same thing with here, we need to work out an expression. There's some overlap here with the very first chapter that we did as well in putting together linear equations. So you're starting to use, again, skills that you've already covered a little bit earlier. Same thing for this. I'm just going to move through this because they're all similar type problems. Well, this one was a toughie. We needed to use perimeter, and we needed to also use Pythagoras. I'll leave you with that. I've explained it in here, but I thought question 8 was a bit tough. Now we look at inequalities. Now inequalities, notice equation, no one really realises. It starts with the word equal, or it's almost equal. That's what it means. So an equation means you've got something equals something else, like this. That's an equation. An inequality means where one side is somehow related but almost equal, but you've got these signs here: less than, greater than or equal to, less than or equal to. And so this expression here, if it was an inequality, would have a greater than or a less than sign or something. Any of these here, it would be an inequality. Now, as a rule, when you're trying to solve these, you can often treat them as if it's an equal sign like this, pretending that it's equal, going through and ending up with changing it back to whatever the sign is at the last minute. Doesn't always work, but that's a way that you can look at it.